Perfect. Good evening, faculties and students. I'm Dr. Arunkumar. So from SRM IST Katankulattu, the automobile department. So I cordially welcome you all to my presentation. Okay, especially on the 4th day of the 6 days workshop on the future trends of automotive drives. Okay, so let us go to the outline of the presentation. Okay, basically the agenda. So to begin with, let us have a the need for the automotive electrification. Okay, everything comes with the need and the necessity. So to begin with, we will be starting with the need for the automotive electrification, the various types of electric vehicles, the fuel cells and the types. Why we are going for fuel cell based electrical vehicles? Because when you are going for some technology, there must be some problem with the existing technology, isn't it? So that also we can concentrate. Then working of the proton electrolyte membrane fuel cell. Okay, there are many types of fuel cells, and we will be concentrating predominantly on proton exchange membrane fuel cell. Okay, so the architecture of that fuel cell electric vehicle, the battery electric vehicles versus fuel cell vehicles, and also apparently we can see a video, the global scenario, how it is there, and the Indian context. So coming to the, apart from that, every technology is driven by some sort of, the political thing also. So how the Indian fuel cell electric vehicle is marching, that also we can see. Apart from that, the fuel cell EV deployment, the hydrogen economy, because hydrogen is the fuel for the fuel cell. So you need to know about the hydrogen economy, because being a fuel, the clean fuel. So you need to know about the hydrogen economy, the key players in this field. Okay, this is a new field, and there are many key players. Okay, so we need to know about them, and we can conclude. So the need for automotive electrification is, it is very evident. Okay, we are making a transition towards the electrification, either in terms of battery electric vehicle, or it can be even the fuel cell electric vehicles. Okay, so for any work to be done, okay, whether it is for mobile application or automobile application, so the fundamental component is nothing but the energy. Okay, so you must be very much evident with that. Okay, the limitation with the conventional energy source, basically I'm talking about the IC engine. So it is causing a lot of environmental issues. Okay, so the most polluted city in the world, which city? The capital city of India. Okay, so the New Delhi. So it is one of the most polluted city, and among the top 10, there are almost five cities from India. Okay, then Lucknow, Kanpur, and a few more cities. Okay, they are very much polluted. Okay, the transportation sector, it contributes to 4.2 tons of carbon dioxide. Okay, carbon dioxide is what? It's not only a harmful gas, but it's also a greenhouse gas. Okay, so and also apart from that, there are many particulate matters. Okay, there are many and COx and NOx emissions. This leads to a death of about 3.3 million death rate per year. Okay, so apart from these are that the medical implications or the environmental implications. Apart from that, there is also a GDP. Okay, so there's always some sort of business that is hidden, and we can see the petrol or the diesel price is nearing already it has reached, okay, the century. So as a consequence, we need to go for electrification. Okay, that is the need of the hour. Okay, so when you take the type of electric vehicles, so basically it is very evident. Okay, the electric vehicles are classified as the battery electric vehicle. Okay, or nothing but it is the pure electric vehicle. Okay, so it is nothing but having just the battery as the primary energy source. Okay, so then the hybrid electric vehicle, one of the good example is the Toyota Prius. Okay, it has, apart from the battery, you have an IC engine, Okay, basically a gasoline or petrol based IC engine. Okay, so this Toyota Prius is a widely used hybrid vehicle model. Okay, so you can see it has, apart from that the engine as well as the motor, they are powered by the battery. Okay, so the battery is charged as and when you go on the move. Okay, so the plug-in, there's one more hybrid vehicle called it plug-in hybrid electric vehicle. It is same as the this hybrid electric vehicle, but however there will be a plug-in option. Okay, so the same hybrid electric vehicle, except there's a plug-in option. Okay, so for example, the vehicle is the Hyundai Ioniq. Okay, so apart from this, the new member in this family is the fuel cell electric vehicles. Okay, so this many of them think fuel cell vehicle is not an electric vehicle, but no, that fuel cell vehicle is also a electric vehicle. Okay, it is the same thing. It is as a motor. Okay, however, instead of a battery, okay, you have a hydrogen and a fuel cell stack. Okay, sometimes battery is also used. Because to power the auxiliaries and also to recapture the energy during the braking, basically the regenerative braking, because battery is both the input and output is electric energy, both on the charging and the discharging, whereas in a fuel cell the output is the electrical energy, whereas the input is the chemical energy from the hydrogen. So you can't give electrical energy back to a fuel cell. Okay, so that is the purpose we use battery. Okay, in case of a fuel cell electric vehicle, a small battery. Okay. So coming to the fundamentals of the fuel cells are actually electrochemical energy conversion systems, very similar to the batteries. Okay, they convert the chemical energy of the fuel into the electrical energy directly. Okay, unlike the existing system where the chemical energy is converted to the mechanical energy in the IC engine, and from that it is converted to the electrical energy through a generator. Okay, so since here the chemical energy is directly converted to the electrical energy, there is a lot of scope for the conversion efficiency. Also in IC engine, so it is subjected to the chemical energy is subjected to Carnot limitations. Okay, so there is the heat engines are subjected to Carnot limitations, and this limitation is not there in the electrochemical systems, whether it's fuel cells or batteries. So coming to the types of fuel cells, basically the fuel cells are classified based on the type of the electrolyte we use. Okay, so for example, we have a solid oxide fuel cell which uses a solid oxide as a electrolyte. Molten carbonate fuel cell, it uses molten carbonate as an electrolyte. Alkaline fuel cell, that uses alkaline medium. It can be potassium hydroxide or sodium or something. It is used as a electrolyte. And phosphoric acid fuel cell, that uses phosphoric acid as an electrolyte. Okay, and this direct methanol and PEM fuel cell, they both same family. Okay, they belong to the family of proton exchange membrane fuel cell, and they use the proton exchange membrane as an electrolyte. Okay, so these are the fuel cell types. Okay, so these are the fuel cell types, and the fuel used are apparently these are the fuels. Okay, for high temperature, you can see that even the carbon monoxide or can be used as a fuel. Okay, so they can contribute to sustainability. Okay, so for here in this contest, we will be concentrating on the PEM fuel cell. Okay, which has a temperature of operating temperature of the room temperature to 100 degrees Celsius. Okay, mostly 80-90 degrees Celsius, can go up to 100 degrees Celsius. Okay, so the same, the fuel cell is the electrochemical system, same like a battery. It comprises of the anode, cathode, and the electrolyte that is separating the anode and the cathode. Okay, so what is the need? We go for fuel cell electric vehicle. Okay, because there's some problem with the battery electric vehicles, especially with regard to the cost. Okay, so I don't want to mean that fuel cells are cheaper, but being at a very early stage, and they have the potential options to be much cheaper. Okay, then with regard to the energy, okay, India has a low resource of lithium content. Okay, still India doesn't have a high lithium content like either China or Australia or US. Okay, then again there is a problem with the impact on the grid. Okay, because if you take a battery vehicle, it has to be charged from the grid. Okay, so when everyone are charging at the same time, that will cause a serious impact on the grid. Okay, that also you need to consider. And apparently it is well evident. No, we know the charging time is very high. Okay, so in the modern, in the fast world, you can't wait for a few hours, to charge. Okay, the charging, obviously the charging infrastructure, which is also contributing to the range anxiety. Okay, so the limited range. So coming to the principle of the proton exchange membrane fuel cell, I told previously in the previous slide itself, among the various fuel cell types, the proton exchange membrane fuel cell is the most widely used. The reason is because it has high power density, low operating temperature. Okay, so as I told, in a fuel cell, the chemical energy is converted directly into the electrical energy, same as the battery. Okay, but however, in battery, the chemical energy is stored within the battery, whereas in fuel cell, the chemical energy is stored externally in a hydrogen tank. Okay, that is the reason it can be refueled very fast. Okay, you need to understand what is the reason. The fuel cell is the charging infrastructure is very fast, because due to this reason. Okay, it is like a gas filling. Okay, so coming to the principle, at anode, oxidation takes place. Okay, there's a hydrogen from the tank we are giving to the cell. Okay, so basically it is the anode. Anode is the part where the oxidation takes place. We all know, we are studied in the school itself, oxidation is nothing but the loss of electrons. Okay, so the hydrogen is splitted into on oxidation, it splits into a proton and electron. Okay, proton and electron. The membrane, okay, which is separating the anode and the cathode, okay, this will conduct only the proton. That's why it's called proton exchange membrane. Okay, it is conducting only proton, and it will insulate. It will not allow the electron. Okay, so the electrons will need to travel through the external circuit. So obviously we know what is the flow of electron. What is the flow of electron?
So production of electricity.
Yeah. So the flow of electron contributes to the electric current. Okay.
Current.
Yes. Perfect. Yeah. Exactly. So at the external circuit, the oxygen, okay, or the air recombines with the proton and the electron to produce water. So that is the reason water is the only byproduct. Okay. So coming to the architecture of the fuel cell electric vehicle, so you can see the fuel cell stack. Basically, fuel cell stack comprises of number of cells connected in series, same as a batteries, because the single cell voltage is very low. So you need to stack it, connect many cells in series. Okay, so that is the fuel cell stacking. And the next part in the architectures is the DC-DC converter. Okay, because when you take a fuel cell, it produces variable DC voltage that has to be converted to the fixed DC voltage. Okay. So, and obviously, the vehicle, the Toyota Mirai, any fuel cell based vehicle, they use which type of motor? They use predominantly the AC motor. Okay. So you can't give the directly DC, that has to be given through the inverter to convert to AC and to the drive. Okay. So there will be also some auxiliary devices, okay, like LED lamps and all the lighting for applications that battery can be used. And apart from that, another application of battery, as I told, is the regenerative braking. Okay, because when we apply, you might be familiar with the regenerative braking concept. So while applying brake, the motor will behave as a generator, generating the energy that will be given to the battery to charge the battery. This can potentially enhance the range of the battery, because that power generated, you can't give it to fuel cell stack, because in fuel cell stack the input is what? Input is a hydrogen. Okay. So this concept you need to understand. This is the fundamental, the fuel cell EV architecture, and you must well understand this part is going to be the same for the same as that of a battery electric vehicle. Okay. So what is the other reasons we go for the fuel cell based electric vehicle is that they have a very high energy density. Okay, because energy is the very essential factor. And when we compare it with the US ABC, basically the US Advanced Battery Consortium, you can observe that compared to the lithium ion, the energy content of the hydrogen and the fuel cell system is very high. Okay, and that is the essential requisite of a any automotive system, okay, because for a transportation application, the power density is very essential, okay. So we all know, okay, the IC engines, they have a very good energy density. If a system, okay, if a power system has to be compete with this, it has to be have not only a good energy density, but also a good power density, because we need power for good performance. We need more energy for a good external range, okay. So you can take one example, Usain Bolt, okay. He has a very high power to win in a 100-meter race, but does he has energy to win in a marathon? Kindly reply, yeah. So there are two different fields, okay. For a 100-meter, you need more specific power, okay, whereas for a marathon, you need more energy, okay. So all these constraints based on the Reagan plot, okay, we have to design. And obviously the fuel cell system, they have a potential, okay, potential specific power as well as energy, okay. It is very well evident, okay. Moreover, one thing you need to understand, any batteries, no, when we are discharging at a very fast rate, they rapidly lose their energy content, okay. So at least you need some sort of auxiliaries like supercapacitor, something to which can be potentially operate in hybrid when we need of high speed or something, okay. So any system have some sort of problem, okay. In case of batteries, you have a battery management. In fuel cell vehicles, we need a thermal management, okay, because in a fuel cell, equivalent amount of thermal energy is produced in addition to the electrical energy. For example, a fuel cell is operating at a 50% efficiency, it produces equal amount of thermal energy, okay, or thermal power. For example, a 1 kilowatt fuel cell stack operating at a 50% efficiency produces 1 kilowatt of thermal power, okay. So that thermal power, in case of stationary applications, stationary means, you know, for space heating or something, we can make use of it, especially, you know, in cold countries like Canada, Japan or Europe, okay, they convert the electrical energy to heat. But whereas in case of fuel cell, you get it as a waste heat that can be used for space heating, okay. But however, for transportation application, this waste heat, you know, it is not giving we can't make use of it. So you need to reduce it. We need to properly manage it. So anything, if you want to properly manage, you need to have a very good measurement, okay. So you have a thermocouple and a thermal management system, okay. So this is a comparison between a battery electric vehicle versus a fuel cell electric vehicle, okay. You can see we have compared the two state-of-the-art vehicles, okay, on the same year, okay. For this is also 2020 configuration, this is also 2020 configuration. This is Tesla, okay, the US versus the Japanese Toyota Mirai, okay. So they with regard to the power conversion, obviously, you know, the electric vehicle has to be charged through the grid, okay, through the grid, battery and motor, okay. As fuel cell EVs, it is through the station, something like a station, and the curb weight is there's no almost 100 kg, I think there's a difference. And the recharging time, you can see it is normal conditions 5 hours. Even with supercharging, it takes 25 to 30 minutes, okay. So whereas in a fuel cell vehicle, as fast, as rapid as a existing technology, okay, because just you're fueling the hydrogen, okay. So coming to the range, also there is limited range compared to the FCEVs, and the energy capacity, it's 80 kilowatt hour and 120 kilowatt hour, okay, because the hydrogen has the highest energy density, okay, in terms of the gravimetric value. So just with the 5.6 kg of hydrogen. But however, the storing is that is a problem, okay. The volume wise, there's a constriction, there's a constraint. But however, no, with regard to the mass, the gravimetric energy density, there's a good potential. The efficiency is obviously it is grid dependence, and it is not reliable. But whereas here it is up to 60%, and greenhouse gas emission is also much lower. And the performance, obviously, the battery electric vehicles, the Tesla is good. Okay, so these things and all you can observe. Okay, and also the production impact, it has an energy source effect, and it's relatively less. Okay, because the lithium batteries, it might cause some kind of impact, sustainability issues in long term. So now I thought of sharing a small video that compares the fuel cell and battery electric vehicle. So can you? So actually we have some issues in the thing. Hello, is my voice audible? Okay.
Yes, sir.
So I will share the YouTube link. Okay, the Google chat might be you can go through that. Okay, so you can have a comprehensive thing. Difference between the fuel cell and the battery-based electric vehicles. So I will put it in the chat part. Okay, might be before the end of this thing. Even right now, I think I can do it. Okay. So I have shared it in the chat. Okay, might be you can go through that. So to have a much more insight. Okay. So okay, now we can go back to our presentation. So can you view the screen?
Sir, yes, sir. Yes.
Okay. So now actually. Okay, coming to the global scenario, we are observing that all the many countries, they are starting from Germany, US, Japan. Okay, they are making a transition. Okay, so obviously when you are making the transition, it's you need first to establish a refueling station. Okay, so only when there's a refueling station, the people get confidence. Okay, for the thing of that. Okay, unlike that the battery thing. Okay, always there's a kind of chicken or egg problem. Okay, chicken or egg problem. No, whichever comes first is going to win the race. Okay. So Germany has given the US dollar of 1 billion scheme and US dollar of 1.2 trillion by the bipartisan infrastructure. Okay, through the fuel cell electric vehicle, and obviously the US California fuel cell partnership program. It has a certain time. Okay, because these fuel cell stacks must satisfy the certain durability. Okay, to especially when we need to compete with the IC engines. Okay, so to be followed by Japan, China, and India as well. Okay, so they are the key players. So you can see. Okay, so the rate of increase in the stock has been very exponential. Okay. So with regard to the Indian contest, okay, actually it was initiated by the minister Nitin Gadkari, I think March 2022. So in fact, he drove the vehicle, the Toyota Mirai, to the parliament through this car. And obviously, if it is there in Delhi, obviously somewhere near Faridabad, it should be the NCR region. So it is there in they have installed a hydrogen station. And there's also the global first hydrogen powered auto rickshaw. Okay, is there in the Delhi? It's in the yearly 2012 itself. And Tata is also doing a lot of research. Okay, in the case of the using the transport for the vehicle, and also the Hyundai followed by the Mahindra. Okay, so these are the various the roadmap. Okay. So apart from that, the government is also taking initiative to mix hydrogen and CNG, because smooth transition is always a better option. No, instead of make a sharp transition towards the hydrogen. So the first stage you can mix it with the hydrogen and CNG. We call it as hethane also. Okay, there's a combination of hydrogen and methane. So there's a thing hethane, and gradually we can, by end of 2040 or 50, we can be a pure hydrogen. Okay, the pipeline has been can be made. So coming to the Indian fuel cell electric vehicles, okay, many of them have that thing. They are afraid of fuel cell vehicles since they are using hydrogen tanks. Because the reason they are, because they haven't understand the principle. That is, I will say that is the reason. Because when you take hydrogen bomb, the principle is what? It's a fission or fusion reaction. Okay. Whereas the fuel cell, the principle is electrochemical reaction. Okay. So in no way they haven't understand the principle. Okay. That is the main reason I will consider. So you no need to worry. To be honest, hydrogen is the most safest safest gas. Okay. So provided, obviously, we need to have some kind of safety measurements, hydrogen sensors and all those stuff. That is obviously safety is essential part of any engineering design. Okay, so that you need to understand. And with regard to the manufacturing, also the government needs to subsidize. Okay, because the initial the trust must always be initiated by the government. So this is, as I told, this is India's first fuel cell-based electric vehicles, and the Toyota, along with the International Center for Automotive Technology. So under the mission of the National Hydrogen Mission, okay, this is the central government's initiative, initiated by the Minister Nitin Gadkari, and he drove the car, on the 16th March 2022 from to the Parliament. Okay, actually the word Toyota Mirai means future. Okay. The word Mirai means future in the Japanese word. Okay, so this is seen to it's one of the PM's, the Prime Minister Modi's dream of Atmanirbhar Bharat. Okay, so this is a scheme. So they have a range. Okay, because when you take electric vehicle, we always concerned about the range. Okay, in fact, the problem with the electric, the battery-based electric vehicle is also the range, limited range. Okay, the Tata, we have seen now the Tata Nexon failed to satisfy the thing, the range that it is claimed. Okay, in fact, that caused a lot of issue as well as. And apparently, the refilling time also not 8 hours or 10 hours, it's just 3 to 5 minutes. Okay, these are the unique attributes. Okay? So that you need to understand. And obviously, there's no tailpipe emissions. Okay, so except water, because we know the reaction is very simple. Hydrogen reacts with oxygen to produce water and the electric energy. Okay. So coming to the fuel cell electric vehicle deployment. Okay, so actually this is this chart is based on my publication that I made a few years before when I was in New Zealand, Auckland, and in fact it is one of the highest cited paper in the IET transportation. So let us see the various PEST analysis I have made. Okay, basically when you mean PEST, it is nothing but the political factor, economical factor, social, and the technological. Okay, so the initial thrust must be always from the political thing and the government, and so obviously the oil import. Okay, how much is going to impact, okay, on the transition. And there's also with regard to electric vehicle job opportunities and the scope of policy framing and homologations. With regard to economical, there's a public deployment and this fuel cell electric vehicle industry and the infrastructure. Okay, so and also overall the cost of the fuel and the ownership. Okay, that is the essential attribute. And again, with regard to the social factor or the sustainability is a very important thing. Okay, because not the technology alone is not a matter. So when you take the social factor, the safety and the emission concern, the feasibility and the viability. Okay, so I think you need to know the understand between difference between feasibility and viability. Okay, so because feasibility means it is more of technical aspect, viability is of the business perspective. Okay, not all the technical feasibility is we can't be considered as a viable. Okay, so and intersection of the technical feasibility, there's a viability, there's a scope for the sweet spot of innovation. Okay, that is from the business perspective. So, and apart from that, there's a development of long-term usage and adaptation. That is also an important social factor. Coming to the technological, there's a scalability. Okay, when you take any business as well, scalability is essential process, and also the onboard hydrogen storage. Okay, so because hydrogen is the fuel, and appropriately it has to be transported in the vehicle. Okay, so and regenerative braking. Whenever there's a EV, there's an option of regenerative braking. Okay. So, and also the various control aspects. So, when you take the fuel cell technology, obviously hydrogen becomes a part of a fuel cell technology. We can't separate hydrogen and fuel cell. In fact, the fuel cell principle, the fuel cell operation by itself is the reverse of the electrolysis. Okay, so because at this point of time, I must tell what is electrolysis. Okay, electrolysis is the process where we generate hydrogen from water. Okay, in fact, that process only we call it as a green hydrogen. Okay, and especially when we are using that renewable energy, okay, to produce that hydrogen. Okay, so we all know that hydrogen economy is becoming envisioned as a in which hydrogen is a potential fuel. Okay. So the cost of the gray hydrogen, when you mean gray hydrogen, it is nothing but the hydrogen that is produced from the fossil fuels. Okay. So always remember, okay, the conventionally more than 90% of the hydrogen that is used is produced from the steam methane reforming. It's almost like a same petroleum only. Okay. It's a hydrocarbon actually. Okay. So that is the reason, it has to be, we need to make a transition towards a green hydrogen. Although the cost of production for the gray hydrogen is much cheaper, so it cannot be considered as sustainable. We can consider sustainable only when it is through the renewable source, and there is a potential contribution to the environment. Okay. So ironically, the green hydrogen cost is much higher. Okay, even with the cheapest renewable power plant, but the scope for improvement is very much high. So we can easily consider the cost of hydrogen to be 150 rupees or 200 rupees per kg for green hydrogen in the near future. Okay, because especially when you take that wind power plant and all, most of the times you can observe the capacity factor of the wind power plant is very low, some 20%. Most of the times it is waste. It is not at all working, not efficiently used. So at that point of time, use that wind power to generate hydrogen from water. Okay, store that and use it when on demand. Okay, that is in fact the principle of the green hydrogen. We can see that is this wind power or other the hydel. Okay, or the solar PV. Okay, we can use any of the renewables. Okay, to generate the hydrogen. Okay. Apart from that, the hydrogen economy not only is used for the transportation. Okay, it can be also given to power the grid. Okay, and also for fertilizer. Okay, there's a technology, ammonia is the fertilizer, and we know hydrogen can be converted to ammonia. That's one process. Can anyone say what is the process? Conversion of hydrogen to ammonia. The famous process, we call it as a Haber process, which is this is a fertilizer. In fact, fertilizer also is very essential for Indian economy, leading to the sustainability, because agriculture is the backbone of Indian economy, isn't it? So overall, this hydrogen economy can contribute to the well-being of not only the society, for the nation as well. Okay. So these are the very things that we need to consider, and especially in the terms of long term. Okay, from the long term perspective. Okay, so thus we can see that can be used for transportation. For that, there's you can provide a separate option is there. Okay, so in small tanks, and in fact, this by itself can be a business. There's a lot of business potential for the hydrogen itself. Okay, so currently we have CNGs or LPG. In future, probably we can have hydrogen fueling stations, or it can be through the hydrogen bottles as well. Okay. So coming to the conclusion here, the US Department of Energy, what they have claimed is they have claimed that fuel cell electric vehicle is a superior candidate compared to the lithium-based ion. Okay. Although the Elon Musk belongs to US. Okay. Still they are supporting the Japanese fuel cell leader, okay, the Toyota Mira, because of the various reason. Okay, it causes it's obviously the power density I told is very high. It generates less greenhouse gas, and long-term sustainability is very, very high, the potential, and it costs less time to refuel. Okay, so you can't wait for 8 hours, and we are thinking that supercharging is possible, but to be honest, when you are charging, supercharging means what? Mobile also we have fast charging. What happens? We are increasing the current. When we increase the current by Joule's law of heating, what happens? The temperature is also increasing. When temperature is increasing, obviously the system is going to be damaged, but at a faster rate. Okay, so these kind of fast fast charging, rapid charging, that they can't give a long-term sustainable thing. Okay, because you are by increasing the current, obviously we are decreasing the lifetime of a battery. Okay, so that is also one issue that you need to consider, and obviously it is also requires less well-to-wheel energy. Okay, that also you need to consider. And apart from these factors from Indian context, this is from the US context, I will add one more valid point for the Indian context. In India, there is no sufficient amount of lithium ion. Okay. Without a proper resource of lithium ion, how can you build a battery? Okay. So again, we need to depend on China. Okay. China. So depending on China is worse than depending upon Middle East countries. Okay. So obviously what I feel is the fuel cell is a potential option. Okay. Because we are not using metals like lithium or something. Carbon is sufficient. And of course, we are using platinum catalyst. As time goes on, we are in fact, my group, they are working on CNTs and various advanced catalysis by using 3D printing technology. So, and also the flow field plate, as I told, that is the plate. We are also using myself and my team. We are working on the composites by 3D printing for these kind of flow field plate fabrication, which can reduce the cost. Okay. So these are the key players. They are working on this kind of the fuel cell stacks. And obviously, Ballard is the leading fuel cell thing. And Bloom Energy, there's a company. It's a very good Fortune 500 company. It was installed by a professor from his name is Steer, I think. He is a NIT alumni. So this is Bloom Energy. They work on solid oxide fuel cell, not PEM, but so solid oxide fuel cell, and so a lot of stack supplies are there. Coming to my green vehicle, our research center. We are working on, as I told, the polymer-based flow field plates for PM fuel cell applications and various thermal management issues. Okay, we are working on smart nanofluids for this kind of thermal management issues. So I want you to ask one question. Okay, removing low-grade heat and removing high-grade heat, which is the simplest process? Can anyone tell? Removing low-grade heat versus removing high-grade heat, which is the simplest?
Obviously, the low grades.
Yes. Okay. So the greater, in case of IC engine, the temperature, operating temperature is very high. So easily you can remove the temperature from the system. But whereas in case of fuel cell, it is evident the operating temperature starts from the room temperature to 80-90 degrees Celsius. Removing a low-grade heat from a system is very difficult. Okay, so we are working on advanced smart nanofluids. So our team are working on that, and recently we published few articles as well. So in kind of peer-reviewed journals. So my research coming to my team, Dinesh is working on the 3D printing technique to fabricate the flow field plates, and one more student, I'm acting as a co-supervisor. He's working on the smart nanofluids for PEM fuel cell application. And one more student, he's now working on other application, not non-fuel cell energy application. Okay. So I am collaborating with Kishore Kumar Sadasivani and Professor A.M. Kannan from Arizona State University, and my former supervisor, co-supervisor, Sat Singamani from Auckland University of Technology. So I'm doing wide area of research, starting from the the flow feed plate and a new catalyst, and from the thermal aspect, I'm working on the nanofluids, and so the research is going on and on. So apart from that, I have a startup, and we are working on to fabricate a cost-effective fuel cell components. So this is the name of our startup, 3D4S Systems, and you can visit it. So we work on various 3D printing technology to fabricate not only fuel cell but also solar PV components and solar thermal components. So solar PV, basically, you might have heard of there's one vehicle called Lightyear One, from Netherlands. They are working on the solar PV as well. So what I feel is solar PV can complement either fuel cell or battery electric vehicles. Even if you are able to get some 20 to 30 kilometer range extension, that will be of a greater contribution. So apparently we are also aiming to innovate various innovations and educate students on sustainable technologies and the sustainable development goals. When you mean sustainable development goals, so there are totally 17 sustainable development goals. It is formulated by the United Nations for the well-being of the nation, not only the nation, for the global, okay, for the global thing. Okay, so we work on various the sustainable development goals, starting from the good SDG 3, basically for food packaging. This is though not directly related. Then SDG 7, the affordable and clean energy, basically fuel cell and solar PV, industry innovation and infrastructure. So of course the manufacturing part, innovation part, and so like this we work on diverse sustainable development goals. So thank you to everyone. Okay, thanks for attending my presentation. Feel free if you have any queries to be addressed. Okay, I'm happy to answer.
Thank you, sir. Thank you so much. Thank you so much. Excellent preparation.
So welcome, sir. Welcome, sir. Welcome, sir. Thank you, sir. Thanks, sir. Thanks, sir.
Doctor, I have one small question.
Yes, sir.
Doctor, actually, you told about that Toyota Mirai. Shall we
Yes, sir.
know that what
Yes,
is the
sir.
cost of that vehicle, Doctor?
So it costs around 60,000 USD. It's almost quite comparable to the Tesla advanced model as well. So it's 60,000 USD. Yeah, it's any electric vehicle, it's still cost only. Okay, it's expensive, but even the mobile we used. Okay, what does for the same configuration you can compare it 10 years before. If same configuration, if you have your mobile, what will be the cost? Might be a factor of 10x
more. Okay.
So, but the scope, especially with regard to the Indian contest, being practically analyzing, so you don't need to depend upon any lithium source or expensive metal source. Okay, the transition source, metal source, because India has a very low amount of this kind of resource, the existing resource for battery manufacturing. Because if you see that assessment made by US, they concluded that fuel cell is a potential candidate, despite US has a very good resource of lithium. So from India, we are absolutely we are nowhere with. No, we need to depend on China, and it's this causes a political thing. No, it's again these things.
This may increase.
They're just adding the.
Yes. Thank you, Doctor. Thank you, Doctor.
Welcome, sir.
Sir, good evening, sir. Am I audible, sir?
Yes, sir. Yeah.
Sir, I have a small query, sir. This is Satish Kumar.
Yes, sir.
Sir, what is the scope for direct ethanol fuel cell research?
So very good.
Compared
So
to
in fact, excellent. The good question. I will like to appreciate this. So when I did my MS by research in the Institute of Energy Studies, I actually compared various alcohols for for fuel cell applications. So the problem with I'll tell any alcohol, not limited to ethanol. Methanol is more widely used, in fact, compared to ethanol. It is for limited applications. A few wattage, 500 watts. 100 watt to 500 watt. Okay, in that range for portable application, this direct ethanol fuel cell or direct methanol fuel cell is a potential option. But when we go for a transportation, or electric vehicle application, you need a power range of up to 100 kilowatt. So for such a thing, the direct ethanol fuel cell is not a very good option. Okay, but in future, okay, there's some problem. We call it as a fuel crossover from anode to cathode. Okay, so these are the limiting factors of the direct alcohol fuels, whether it's direct methanol or direct ethanol. But the good thing for stationary, small stationary application or for portable application, it is a potential option for charging mobile phones or data centers or small applications. Okay. Because the advantage, just a minute, one more thing I want to say.
Yes, sir.
The advantage is the fuel storage option is very simple in direct methanol and ethanol. Okay, for direct methanol and ethanol, that's because we don't need to worry about the hydrogen storage, the tank. That is one of the limiting factor with the existing technology. So transporting methanol or ethanol is much simpler compared to transporting the hydrogen. So moreover, we can use the existing infrastructure itself. Same for the petrol. The same infrastructure can be used. But it's a good question. But one option with using ethanol is we can use a reformer, small compact reformer with a vehicle. So what is a reformer? It converts a hydrocarbon fuel into a hydrogen. Okay, so that option is also there. There's a lot of compact reformers and work is going on that as well.
Thank you, doctor. Thank you for your presentation. Thanks.
Thank you. Thank you.
Participants, is there any other questions?
Sir, Satish here again. Sir, am I audible, sir?
Yeah. You're audible.
Sir, is there any fabrication facility available in your end regarding direct alcohol fuel cell, sir?
Yeah, we are, we are developing our lab, and we are in the process actually. So to develop this kind of microfabricated, the various the diffusion layer and the flow field plate. We are in the process. Very soon we'll be, it will be installed.
Oh,
We
thank
have
you,
already
sir.
given
Thank
the
you so much.
proposal. Yeah, we have given the proposal. Yeah.
Thank you so much, sir.
Sir, Satish sir.
Yes, sir. Thank you, sir. Thank you so much.
Sir, I just wanted to add upon, sir. Just like when you use direct methanol fuel cell, there is one thing
To understand that CO2 is sent out. So again, it
It's not
greenhouse gases.
absolutely sustainable, but relatively it is cleaner than IC engine. But still, it's a small amount of CO2 is produced as a byproduct in that reaction. Any ethanol alcohol, not only ethanol, methanol, propanol, anything if you use, carbon dioxide is produced. Okay.
Yes, sir. That's why I was thinking about bioethanol, because somehow you can contribute. I mean, CO sequestration in plantations. So bioethanol can.
Yeah, that is a good process. That can be more sustainable actually. Bio.
Yes, sir. So if you are able to
There's
produce,
also some project they work. Yeah, tell me, sir.
if you are able to produce good quality bioethanol equivalent to
Yes.
synthetic ethanol,
Perfect.
that can be. Yeah, that
makes
can
sense.
be
Absolutely makes sense.
CO2. CO2
perfect.
emission can be addressed.
Yeah.
Yes, sir.
Yes. Apparently, there's one research going on. Yes. Yeah. Apparently, there's one research going on where they take sequestration, like same as taking our carbon dioxide from the atmosphere. From that, you combine with some kind of hydrocarbon and you generate methanol. So that is also, that is still it is it is a sustainable option. So no
yes, sir.
need to depend upon any hydrocarbon instead of any reforming process. You can go with this.
Yes, sir. That is also a very good option, sir. Yes, sir. Sir, thank you very much for your enlightening presentation and answering, sir. Thank you so much.
Welcome. Is there any other question? Participants, we are ending up today's presentation. Sir, I would like to thank Dr. Arunkumar Jayakumar for this wonderful presentation.
Clearing people's doubt. Thank you, sir.
Thank you all.
I